In method 2, we again look at the same problem, but with a slightly different approach. Again, we rewrite ds as the square root of dx squared plus dy squared, but now we pull out dy. So here x prime represents dx over dy. So we are taking y as our independent variable and x as our dependent variable. So our f here is f of y comma x prime, and we are solving for x of y. Now, strictly speaking, there is an issue here because x of y is not single valued. After all, the curve would look something like this. So at a given value of y, there can be two possible values of x. So it's not really a function. However, locally, it still appears like a function. And that is what our Euler-Lagrange equation is going to really examine. And at the necessary step, we will revert back to y of x. And when I say locally, it's still well defined. What I mean is that if you take any small patch of the curve, it doesn't matter whether you're looking at y of x or x of y, it is single valued. It doesn't cross itself in every single spot or be double valued in every single spot. So now that y is our independent variable, our Euler-Lagrange equations will look like this. Our f in this case is 2 pi y square root of 1 plus x prime squared, but we notice that there is no x dependence. And so the partial of f with respect to x is 0, which tells us that partial f partial x prime will be a constant because you have this side is 0. So when is a derivative of something give you 0, it's when the term inside is constant. Following through, we have 2 pi y x prime over square root of 1 plus x prime squared equals a constant, call it C3. Square both sides, absorb some stuff into a new constant, solve for x prime, and then finally rewrite x prime as dx dy and separate variables. Once again, to make our integral look a little bit prettier, we define a new variable v, and this brings it into a standard integral form. Again, pick up another integration constant. But here is our final solution, which, as you might notice, looks pretty similar to the one that we got in method 1. And so we noticed that this method, compared to method 1, involves less guesswork or sudden flashes of insight, and so is a lot easier. And the main thing to keep in mind there is that sometimes in problems you will have a choice of which variable to make the dependent variable and which one to make the independent variable. And sometimes one of those will be easier than the other.